back to my channel again. I have too many requests stating that explain us like how FW Monitor works, how TCP dump works. So today's video is all about that. So I'll be performing the lab for the FW Monitor and the TCP dump and try to explain uh, what are the things you need to consider, what are the things you need to check while performing the troubleshooting with respect to the TCP dump and the FW monitor. So please watch this video till the end, and you will be happy to understand how these things work. So let's work. Let's start. Uh, if you refer this SK, let's start with the uh, FW monitor, and if you refer this SK, you will get a lot of details on how FW monitor works. If you want in-depth details like how the FW monitor works, you can refer this SK. Otherwise, this video is sufficient for you to deliver the work with respect to the FW monitor. So this is how the syntax is for the FW monitor. As we can see, there is a keyword you need to use, which is FW monitor. Then there is expression keyword which they refer as -e, and then you need to use uh, these codes, and under that you need to have this expression in place. So how it can be generated, I have given a different sites for you guys. You don't have to worry about the syntax. If you refer this site for the FW monitor syntax and everything, it will work for you. See, the syntax and everything is get generated. You just have to fill the details here, whatsoever you want, and as per that the syntax will generate here at the top, as you can see on my screen here. All right, just note it down this website. I have also mentioned this website on my previous videos, uh, but for this video just refer this website again. Let me clear my screen and let's go back to the syntax. So as you can see, I have drafted one syntax for your reference. So you have to use the keyword FW monitor, then expression E, and then the actual expression where the syntax is like this. What are the things you are going to deliver? You are accepting that. What will be your source? What will be your destination? And what protocol or the port you are referring? You can specify here. You should have a sufficient space in between. Uh, I mean, you need to have a space in between these two uh, keywords, like source equal to and your IP address, like that. Most of the time it accepts it without the space, but make sure you have a space so you will not face an issue here. When you run this command, a couple of things you need to consider. This is a very important part of it. So when you run this command fw monitor, how you do the verification for whatever the output you are receiving from the fw monitor. So these are the inspection points, and based on this inspection point you will come to know like where the packet is. So for example, as you can see, you will see the inspection point there, small I, which denotes okay, it's a pre-inbound, and it means before the inbound firewall VM. That means, for example, this is your firewall gateway, the packet is coming from this direction. Okay, once the packet hit to your firewall, you will see this small I, like that. Okay, when your packet then when your packet passes the firewall inspection and go to the next inspection point, here for example you will see big I, so it's a post inbound. Once your all the packet get processed with your rules and policies what you have, then you will see big I. After the inbound firewall performance done, if you have a VPN configured, pre-VPN, you will see these pages. So as you can see, it's 11 to the R80 dot 20 and on above the OSS, you will see all these details. Post VPN, inbound VPN, you will see this ID. Then if you have a QoS implemented, you will see this IQ. Post QoS inspection, you will see big Q, IQ. Okay, like that. Once your inspection got passed, and then whatever the netting and uh, routing perform on your packet, you will see small o here. As you can see, pre outbound, all the packets once passes uh, your netting part and routing part, you will see small o, and once the packet is delivered to the outside world, you will see big o, like uh, this one, right? Again, there are a lot of things involved with respect to your configuration. For example, if you have VPNs and QoS, these are the things you can refer, for more details. But scope of this lab is only with the small I, big I, small o, and big O. Comment below if you want more details on, VPN kind of capture. We'll be covering that video as well if you require. So this is what we get for the FW monitor. So as I said, this is a important SK. Go ahead and look into this SK for more details. What we will do, we will first understand FW monitor versus TCP dump, and then we'll run the lab. So now TCP dump is not actual checkpoint utility. It's just a feature who added into the checkpoint, and we can run the TCP dump as well into the checkpoint. So this is how the TCP dump impressions, expressions look like. The syntax look like. So you have to use the keyword called TCP dump. Then you have to specify which interface you want uh, that TCP dump to be run. Without interface, you can run the TCP dump, but for most of the time, for the troubleshooting purpose, we should have the interface with us, and accordingly we will run it. So this I indicates for the interface and gives the interface details and the expressions. So this is how the syntax looks. TCP dump, which interface you want to go for it, and then this is all about the syntax or the expression. Source, what is the source, what is the host, source host, what is its IP address, and what if you have a destination host, you can write it down, okay, DST host equal to like that, and then the specify the port details like that. This syntax and details you will find in various websites, in online, everywhere. Just keep in mind the next part which I am going to explain here. This is all about TCP. So when you find, when you perform the TCP dump command, run TCP dump command, and now you want to do the observation for the output what you have received from the TCP dump. These are the important points you have to think, and based on that, do the capture analysis for the TCP dump. So when you run the TCP dump command, you will see the output in a format like, you will see the different flags there. So these flags are like, okay, you will only see the S. What it means? It means sync, starting the connection. You will see somewhere no flag set like that. Also, you will see P for the PSH flag, which is indicate like if data is pushed. Then you will see F flag, which stand for uh, fin. Fin is nothing but your connection is terminated smoothly. Then you will see the RST flag. RST is nothing but the reset the connections. Okay. So if you don't know how the TCP three-way handshake works, please go ahead and watch my TCP three-way, four-way handshake video. But observing the output for the TCP dump, you need to know what do you mean by TCP three-way handshake. Okay, in three-way handshake, usually, as I'll just explain, you will send a sync packet to the from host A to host B. If the communication is happening between the host A to the host B, you will set sync packet. The host B will give you the acknowledge for that packet. Then host will send that okay, I have received the acknowledge for your sync, and then the communication gets started. It's that simple. So as here you the three-way handshake process is just explained like that. So host is saying TCP sync noise packet to the host B. Host B receive the sync packet. Host B send the sync acknowledgement packet. Host A receive the sync acknowledgement packet. Host A send acknowledgement packet back to the uh, host B, and then connection get established, and then the data transfer will happen like that. So these are the actual flags you need to remember while observing the TCP dump output. So in a bit we are going to run this command, and I'll be showing you all this from the console itself. So I hope this part is clear to you guys. Now let's go to the uh, uh, party session, and let's try to run this command so it will be more clear to you guys. Let me change the appearance here. Let me give it like 16 so you guys can able to see it well. So it's a 192 168 1.101 is my uh, gateway IP address. Let me log into it. Go for the expert mode and run all this command from the expert mode itself. Uh, right now, let me copy the syntax. Let's run first FW Monitor and observe the things, and then we'll run TCP dump. So right now, this is what the communication is going on uh, for my uh, what are the syntax I have given. Let me say Control C. Let me clear again, and just wanted to give you the output. Let me stop here itself. Uh, so this is the syntax we just learned. So this is my source. This is my say one of the server or a PC from where I'm trying to hit to the Google DNS, and I'm doing the ping to this. So it's a continuous ping. I just wanted to show you that as well. So as my topology says, I have this in place. Let me go inside and show you the ping. That will be more clear to you guys. See, this is a continuous ping I have applied. Let me clear it. As you can see, the continuous ping is to the dot, and that output we are seeing from the gateway itself. So let me clear the screen one more time and just run it again. So this is what the things are running. Let me stop here. I just wanted to tell you like how you can observe these inspection points. So in the output says 88.0. Okay, this is my outbound interface from where the packets is going outside world. This is my source IP address of my machine for where I have run the ping. This is the destination IP address the ICMP protocol is running, and this is the ID for each communication. As we know, the type 8 is ICMP, so you will see type 8 here, and you are seeing the code 0 is running, echo request ID also running, and the sequence number also running. Okay, if you come here and check these flags, okay, so here you will see O, small o, here you will see big O, right? So what is happening now? We have the uh, secure Excel enabled. So probably due to that, we are not seeing the small I or a big I flag. But however, just understand now, uh, this small O indicates your natting part and the O is going outside. That means the communication happening. Let's do some trick here with the command. Let me, sorry, let me do something else for the better output. Let's run the command and just run the command for the host. Hope this will work. Yeah. And now let's see FWSL status. Okay. FWSL off. Secure Excel is now disabled. Let's see what changes in output for the same command. So I don't see much change here. But what I want to do now, let's capture this thing uh, over the Wireshark. Let's see how it works. So let me clear the screen and see where I am right now. So I'm at the admin directory. That is fine. Let's capture the output with the say fw of dot cap. Okay. Let's capture a couple of facts and observe in. Let's observe in into the Wireshark, like what is going on, what is missing here, and what we can get it from the Wireshark. What I mean, maybe the some details which are not locating here, we will see on the Wireshark like that. Let's see. So my purpose is, you guys, make you understand uh, how to troubleshoot and how the things you need to verify for such sort of scenarios. And I hope you guys will learn the things and perform the activities during your troubleshooting. So this is what we capture we have. Let me get it to here and let me run the Wireshark. Okay, it's up there. Open, open. Awesome. See, this is the difference, guys. The CLI output and the Wireshark output, right? Let's compare it here only. Let's compare it real quick. Same command I am running. Okay, no difference. If you see, we only able to see two inspection points. Small. Oh my God. Hold on. Only two inspection point. One is your small O and one is your big O. Okay. So from I mean only though two inspection point, we are not able to small eye and big eye here. But when we capture the same thing, we run the same thing from the Wireshark, Here you are able to see all these details. For example, uh, small I, big I, small o, big O. What that means, right? It means all the packet inspection points are get verified and passes, and then the packet flows to the outside world. But when you do the same troubleshooting via CLI, the output is not visible or the way it should be visible into the Wireshark. So this is important, guys. Don't trust more of the CLI. Try to go ahead and capture that file and run into the Wireshark and see how the things looks. I hope this is clear now how the FW monitor works and what are the inspection point we are seeing. One more time, guys. This is pre-inbound. I mean, when the packet hit to your firewall, you will see I. When packet passes the policy inspection, you will see big I. When you pass the routing and the netting part, you will see small o. And when it reaches to the outside world, you will see big O. Okay, guys. So this is all about the uh, captures for the output of FW monitor. Now let's deliver the similar work, but here we will capture the other sort of traffic like 443 traffic from the same machine. So let's do the TCP dump now. So let's run the TCP dump output here, and let's go back here to my Windows server and let me rerun this, whatever it is. Just I wanted to capture some packets. All right. So we have captured a lot of packets here, and let's now observe the things. So as you can see here, we have run the TCP dump. My interface was outside interface. This is my source, and this is the port I wanted to capture. So the output shows this is my source is going to, for example, this side. Okay, let me control C, control Z to stop the output. So this is what my source IP address, which taking source port going to this side or HTTPS port. Okay, and if you remember, I told you about the flags. Here you need to notice the flags. These are the flags. So whatever the things happening with the packets, we are seeing that it's giving me, finish flag, which means the communication is got finished. It's giving me S flag. That means, I mean, it depends on how the packets flows. So I believe the this consider this is my first packet because you will see here sync flag. So this is my first packet. Consider from here. So you will see yes. Then again the sync flag. Then somehow you are seeing the push flag. The data is getting pushed. Okay, and then you are getting acknowledgement here, but however we are not getting the output, so data is trying to get pushed and the output is not appearing as expected. Let's observe the same thing with the uh, Wireshark itself. Let's see what is the difference uh, between the output of the Wireshark and the output of the uh, this command. I think W is the output capture. Let me cross check one more time here. Uh, where is my output file? One sec, guys. It is important to run the right command so that details whatever we are capturing will be the correct. Okay, so here we need to have a small case FW, and then the output file say FW Excel 12.cap. Okay, the capture started. Let's go ahead and rerun this output. Okay, one more time, one more time. Let's see if the packets get captured or not. Okay, so we have the packet captured. Let's go ahead and see if we have anything here. Refresh. Yes, we have the packet captured. Let's run this command file into the Wireshark and see what else we will see. So let me just open that file. This one, and you see this is what the output is, and here you have to observe each and every packet, and here you will see the exact details. So for example, this is number one packet, so let's see the frames, and as you can see here there is packets which flags, sets, and everything details you will see. Let's go a little bit deeper to see what is here at the frame size. So it gives you what is your destination, what is your source, uh, what is your destination, what is your source, uh, what protocol you are talking about, and see here we are seeing this is the sync flag, right? This one. If I want to go with the second packet, third packet, fourth packet, fifth packet, see here you are seeing the acknowledgement flag, then here you are seeing the reset flag. I mean, how the things are happening, you can, observe. If you see here is a fin flag like that, you can observe via the TCPDUMP output from CLI and from the Wireshark. So guys, I hope this video is informative for you, and guys, thanks for watching this video and have a wonderful day.